If you would remember the discussion yesterday, you would remember Sir Bradford Hill's questions. There were 4 of them. So we've answered the first one. Why did you start the study, which is the introduction part of the study? We've answered methods. What did you do? We will answer today results. What did you find? And finally, we will talk about discussion and what does it all mean. So this is what we are going to do today, results and what did you find? This is what we are looking at today. Before I go on to the results, actually, I would like to share with you that there's a book edited by me and Professor Rakesh Agarwal, current director JIPMA. He wasn't director JIPMA at the time when we did this book. It's a multi-author book, lots of authors in it, different countries, and it's a comprehensive book. It tells you how to report and publish research in the biomedical sciences. It talks a lot about what it says a lot of the things that we cover in this course and more. So if you wish to purchase a copy, it's 300 rupees if you buy from the National Medical Journal of India. And if you go and buy an ebook from Springer, who's our co-publishing partner of the book, then the cost is somewhere in some euros, some 75 euros or 105 euros or something like that. So in case you want to purchase this book, at the end of the course, we'll give you details on how you could send in the money and get the book. If there are lots of you who need it, then Professor Agarwal could actually, Amita Agarwal could actually get your names together, send us the money in one go, and we could send you the books in one lump sum packet, and you could then pick it up from our office or however she wishes to get them distributed. Okay, so this is a huge conflict of interest that I have in promoting a book that I have edited along with Professor Rakesh Agarwal. The only reason I continue to do this is to let you know that I get no money from this. This book is sold at almost cost price, and whatever money comes from it, which is 5 rupees per book, I think after we've sent it by post, it goes directly to the National Medical Journal of India, and whatever Springer sends in again goes directly to the National Medical Journal of India. Of course, I edit the National Medical Journal of India, and therefore, in an indirect manner, you could say I benefit from it, though individually I do not benefit from it at all. So shamelessly, I continue to promote the book because I think it's a very a very useful book, which is very well written by the numerous authors who've contributed to this book, all experts in their fields from different countries. Okay, now let's get down to the job at hand, which is results. So what did you find? These are answers to the questions that you've posed right in the beginning. So we did not cover a research question and how to write up a research question because that's not part of this particular course. But I'm sure in other courses you would have heard of how to write a research question. And as a part of writing up that research question, you need to then get answers to your research question and see if those answers are useful to people who might be interested in your research question. Of course, they're useful to you because you've looked at this question and found it important enough. Okay, so before you sit down and write your results, remember there are multiple things that could have happened over the duration of the study period. Most studies, even your dissertations, will last anywhere between 18 to 24 months or more. So if you've been collecting data over 18 to 24 months, you could have collected data in various places. You could have collected it in slips of paper, put them into your white coats, and then forgotten about them. Reached home, pulled out that paper and said, oh God, I can't lose this. And then stored it safely in a file in a register somewhere or stapled it somewhere. You could have actually taken pictures of data that you needed from case sheets, from case notes, So you may have pictures on your phone, or you may have actually sat down very conscientiously on some days, not every day, and filled out an Excel form or a Google form to get all that data in one place. So before you actually sit down and write your results, you need to analyze your data, and you must have all your data with you before you can actually sit down and write out those results. So look at your method section and see what are the variables you said you would study. Once you know what are the variables that you were going to study, list those variables that you mentioned and look for the data for each of these variables. Now, how you collect this data, whether you wish to do it on a physical master chart, get a big chart piece of chart paper and draw out lines and rows and columns on it, or you wish to do it on an Excel form, or you wish to do it as a Google form or whatever, it doesn't matter. But do it whichever way you wish to do it, but do it so that you have all the data at one place. After having placed the data for each of these variables where it is supposed to be, look and see whether you have information that is missing. You would have anyway realized by now you have bits and pieces of information missing at places. You could now go and look for these pieces of information, but it's quite possible that you might still end up with missing pieces of information. It's important to make a note of this because your analysis and your discussion is going to cover these issues that you've come across while gathering your data together. Now look at the data that you have. All right, I mentioned all the variables that were listed in the method section, but there were a few more that I added as I went along. So do I have additional data? If yes, is it relevant to this study? If it is, then I need to look at it carefully and see whether I need to use this. And if I'm going to use this, then I might as well put this along with all the other variables at one place. Prepare your master tables, recheck the accuracy of your tables. Remember, you make an error, you're not going to come back and recheck something unless your summary statistics show you that there is something grossly wrong, which is not very frequent. One or two or three variables where you've done some minor mistake may actually just be missed out. So therefore, recheck the accuracy of all your variables. Analyze your findings, list all of them, identify the important ones. Why do we want to identify the important ones? Because we may wish to highlight these compared to some of the other ones. So obviously in a study that has gone on for 18, 20, 24 months or more, there would be findings, there would be multiple findings. And of these multiple findings, you wish to highlight a few, 1, 2, 3, maybe 4, whatever. Make life easy for yourself and for your reader. You've got a lot of information available with you, so think and plan. Look at it, look at the information available to you and think of how you're going to sequence the information. Look at your method section and see how the information is sequenced there. Is it appropriate to use the same sequence? Is it appropriate to use a different sequence? Is there a lot of information? Will I not be able to fit all this information into a single paper? If I need to split this up into two papers, then do I understand how I'm going to do this? I don't want to repeat information in two papers, and therefore I must be very careful if I'm going to split the data. You do it only if you have a lot of information. And we'll talk about duplicate and redundant publication a little later during the course. Once you've done all this, then identify possible subheadings that you could use. Remember, this makes life easy for you, but it also makes life easy for the reader. And the reason you're writing this up is that somebody else reads up what you've written and then says, wow, this is great work. So if you don't make life easy for the reader, then it's going to be very unlikely that your reader says, wow. Are the results study specific? Do we do things related? Do we provide the results in a manner which relates to the different types of studies? To a certain extent, yes, but very broadly, and that's what we're going to do today, talk a little broadly. We're going to give you broad generalization of what you can put into results and what you should not. So drug trials, animal experiments, clinical trials, cohorts, case controls, randomized control trials, meta-analyses. In all these studies, the results could be study specific, and there could be minor variations in the way you put down your results and list them out. For me, the results have three parts. They have a story, which is your text. They have the tables, which is the meat of your study. And then the figures, which are the dramatization of the information that you've got together. So what we wish to do is to look at each of these components separately. So we'll talk about tables and figures a little later, but let's look at what we should put into the text. Generally, you would talk about the characteristics of the subjects at the beginning of the study. Whether it's an animal study or a human study, irrespective, you would try and give information to the readers to try and understand the population that you studied, their age, their gender, and whatever else you wish to tell them about. You might also want to tell people how normal or abnormal these people were, whether you excluded people, and if you did, why did you exclude them? In the methods, you would have said why, but what kinds of people you would exclude. But in the results, you would say how many you excluded, and for each of these reasons, which ones you excluded. So that's different from the method section, where you just list out the reasons for exclusion. If you have a control group or other comparable groups, then you try and tell people about these groups as well. Generally, you want to tell people about your positive findings first. Sometimes when your experiments go in a chronological sequence, one experiment leads to another, leads to a third, you might wish to go in a chronological sequence. But generally, positive findings first would be something that's important. Also, a primary outcome measured result first, and then a secondary outcome measured result. Use numbers as far as possible. If you wish to use percentages, use numbers and percentages. Avoid percentages unless your numbers are close to 100 or more than 100. Be very careful about the sentences that you write. You shouldn't be telling people things which they could misinterpret and understand in a completely different manner. If you have any unexpected findings, do provide that information. Don't hide it under the carpet. Don't ignore it. Present the information that you have. As long as you're sure that it has been gathered correctly, the information has been gathered correctly, has been measured correctly, and there's no error there. To what degree of accuracy should I present my results? So if I'm doing hemoglobin measurement, if my hemoglobin measurement is accurate to the first decimal point, I provide my data to the first decimal point. When I do summary, I could go to a second decimal point. So there is no point getting results for the third, fourth, or the fifth decimal point. Would I request anyone, Varun Venkat Raghavan, to put off his? Thank you very much.
Venkat, can you mute yourself, please? Varun Venkat.
Nice to see you, Rakesh. Nice to hear you, not see you. I thought you were busy today.
No. I was. I have it on because I have to speak in between, so that's okay. Yeah, fine. Go ahead. Please.
Okay, great. Okay, so if you've got groups made in your method section, if you had 3 or 4 groups of patients that you talked about in the method section, when you present the results, don't ignore groups, and don't suddenly find more groups than you have mentioned in the method section. Why do I say this? It's often that we make groups when we do our study and we say, okay, these are the 4 groups of patients in whom we would look at our results. When we get to the results, when we look at our data, when we start analyzing the data, we find out that group 2 and group 3, the results are really not very interesting. And therefore, we ignore them and provide the results of only groups 1 and 4. Now, that's something that leaves people wondering what happened to group 2 and group 3. You have 2 choices. One is remove them from the method section completely so that people think that your study was actually group 1 and group 4 and nothing else. That would be being dishonest. Be better for you to say, this was group 1, this was group 2, this was group 3, this was group 4. Group 3 and 4 had results which weren't very relevant to us, and we don't present them in any great detail. We discuss the results of group 1 and 4. So you're honest. You tell people you're discussing groups 1 and 4. You're not talking about groups 2 and 3 because you feel are irrelevant. You could, in the discussion section, mention to people why you thought they were irrelevant. Use abbreviations, and we in our day-to-day life use so many abbreviations that we get used to using them. We try and understand, we believe everybody understands our abbreviations. So what we understand as meaning something may mean something totally different elsewhere. When I was an intern in the obstetrics and gynecology ward in the labor room, in fact, SOB had a very specific meaning. When I moved to the medicine ward, SOB had a very different meaning. And when I moved to the hostel, SOB meant something completely different. And therefore, you need to be careful when you use abbreviations. People may not understand what you're saying, but more importantly, they may misunderstand what you're saying. And that's not what you want people to do. As far as statistics are concerned, you should have decided what you wish to use as your statistical tests right up front while doing your protocol. However, use appropriate tests. If you've made an error at that time, correct it now. Provide exact p-values. Don't give me a p is equal to 0.00. I don't know where the 00 ends. So tell me what it means. Less than 0.001, less than 0.001. Or if you've got an exact value is equal to 0.04, that's fine. Do not use multiple tests. Somebody said if you torture statistics enough, you get the results that you want. So don't torture statistics to get the results that you want. But use statistical terms carefully. Remember, these terms have maybe a slightly different meaning in the context of the English language. So what are these terms? Significant. In the context of science, in the context of an original research article, significant means not caused by chance. Correlation means the strength of linear relations between two variables. Random means each element has an equal chance of occurring, and sample means part of a statistical population. So don't use these loosely within the text of the rest of the manuscript, especially in the introduction and the discussion. Figures such as these, 56.78 plus minus 12.34, without something at the end, either a unit of measure or where is this number coming from, indicates nothing to the person who's reading. Similarly, if you provide a person a 16.7% of something, but don't tell them of what, if they don't know what the denominator is, they can't understand what is happening. In the method section, be sure that you've defined your normals, abnormals, what is high, what is low, because when you get to the results, you start writing these without having defined these in the method section. It becomes very difficult for people to understand all these things. Please don't start off your results by saying the results are depicted in tables 1 to 4 and figures 1 to 4, whatever, tables 1 to 7 or whatever. What about demographic data? Generally, data that you did not have at the start of your study is data that goes into the results section. Data that was decided at the start of the study. So if I decided to include 140 patients in my study, that's part of the methods. And the results, I could say, of the 140 patients, so many were excluded because of A, B, and C reasons. But I could very well put the 140 right in the method section. However, If in the method section I say I will take all consecutive patients with an X disease, it's only at the end of the study I know how many I've included. Then this number goes into the results section, not into the method section. Similarly, the description of the characteristics of the study subjects should ideally be in the results section, unless these characteristics need to be described in the method section to actually say which are the patients you are including and how many you are including. Only then would this get into the method section. I should not include in my results any methods, and they tend to creep in, especially when I have very little to say about a small little point. I've forgotten about it in the methods. I get to the results. It's something interesting. I go ahead and write it. It's a variable that comes after the first 4 or 5 variables which are related to my primary and secondary outcome measures. I do not include data for which I do not have methods. I should not interpret data within the results section. And if I need to put a reference at the end of a statement within the results section, then there's obviously something wrong. That sentence should not be in the results section, because the results are yours and nobody else's, and therefore there can't be a reference in the results section. There's an exception. Systematic reviews and meta-analyses, when you present the results, you could end up providing some references to literature that you have reviewed, and therefore there could be references there. But almost never in a typical original research, not almost never, never in an original research article. Any questions at this point in time? I'm happy to answer them. Otherwise, we'll move to tables and figures.
So the data for which method is not included means what? I couldn't understand that line.
So when you do your study, you start off doing your study in a particular manner. As you go along doing the study, you start deviating from the protocol, and therefore you do things which may not necessarily or strictly be within the protocol. You therefore now have data. If you take your protocol methods, the methods, that section that you wrote for your protocol, and without reading it, copy and paste it into your results section, into your methods, after you've done the study, there could be these errors that could creep in. Methods not available, results available, because the methods were never written, because this was never planned. This was something that happened as you went along doing the study. And you found this information to be relevant, and therefore you included it, but you still did not remember to include the method section, the methods for that particular variable that you gathered. Okay, am I clear now?
Okay. Yes, sir, I got
And
it, sir. Okay.
Piyush, can I come in? Sometimes it happens when you submit a paper, and then or before you submit, while you are writing it, one of the authors says, but we have also those data, why don't we add those in? So you do that. Or sometimes when you submit the paper to the journal, the reviewer asks for something else, and you find you have data, so you include the data in results, but fail to include this in the methods. Over.
Got it, sir.
Okay,
Got it,
any
sir.
more
Thank you.
questions? None? Okay. So I then move on to making tables and figures. And you'd say, everybody knows how to make tables and figures. Why is he talking about making tables and figures? I can tell you that on an average, every day, of the articles that we receive, about half have tables which are inadequately done. So therefore, it's important to try and understand what these tables are all about. So the data that you could put into tables could be generally numerical data. Very rarely do you make a text list into a data, just a list of things that you may have done or want to depict or something. And then there are very specific kinds of tables, which are genetic and genealogical tables, which specific kinds of studies would have. So I'm generally going to talk about numerical data tables. So every table has a part. It has a number. It has a heading at the top. It has multiple columns, and each column needs to have a column heading. Similarly, it has multiple rows, and each row needs a row identifier. At the top of the row identifiers, that means the column heading of the row identifiers, is something called a stub, and this is often absent. And the stub is usually written in singular rather than in plural. The rest of the body of the text has multiple cells which need to be filled up. And finally, at the bottom of the table is something called a footnote, because this footnote tells people about various notations that you may have used within the table. These could be asterisk marks, a superscript 1, 2, 3, 4, a superscript ABCD to try and explain what is happening within the table. So that's what your footnote is all about. Generally, use actual numbers, avoid percentages, but if you wish to use percentages, please provide numbers and percentages. 15 to 45-year-old, 45 to 60-year-old. So where are the 45-year-olds? In both groups? Or you decided to put them in one group and then forgot about the other group? Less than 45, greater than 45. You had no 45-year-olds. So you need to be a little careful when you make up these age groups and try and ensure that you get groups which don't overlap and don't exclude people. Have no blank spaces within the table, because a blank space can be misunderstood. Someone may interpret a blank space as a 0. Somebody else could interpret the blank space as data was not available, and somebody else, that's NA, or somebody else could interpret this as data that was not determined or not collected. Now, for each one of these, there could be a different interpretation of the information that you're providing to the reader. All numbers should have units of measure, and I've talked about the decimal place. Use the decimals to the degree of the accuracy of your measurement. Tables must stand alone. What do I mean by that? If I've made a table, if I read a table, I should not have to go back and forth between the text and the table, or even a figure which is adjacent to the table, to try and understand the table. The table must be easy to understand without having to go back and forth between other parts of the paper. There should be no repetition with text or figures. That means don't duplicate information within the text, within the tables, and within the figures. Another reason not to do that is because if somebody asks you to revise your paper and you change the figures at one place and forget to change it at another place, that becomes a problem. Or if prior to submission, you fiddle around with your data trying to clean it up a little bit, you clean it up while getting one number, but didn't clean it up while getting another number. The first draft had some numbers which were all the same. By the time you got to the third or the fourth draft, which you were ready to submit, people had played around with those figures and changed those numbers. Now, this could lead to a scenario where your first reader, who is the editor of the journal, or the subsequent readers, the second or the third or the fourth, depending upon how many people the journal sends the review, the paper for review to, would all wonder why these figures are different. Thirdly, your table must be complete, and I've just shown you the parts of a table, so it must have all the parts there. And finally, it must be accurate, in the sense that the information provided in the table and the other parts of the paper should be similar and should corroborate each other rather than contradict each other. Should I prefer tables or should I prefer figures? Generally, in written text, prefer tables. Use figures only for illustrative purposes. Whenever you make a bar chart, a histogram, or a pie chart, please ask yourself, is it better to put this data as a table rather than as one of these figures? However, remember that there's always a difference in written and oral communication. So if I were to present that same data at a conference, I would use a figure, an illustrative mode, rather than provide the data in a tabular form. So this was a figure that we sent to the Lancet, and the Lancet said, we'd publish your paper, but please send us a table, and we did that. But if I were to use this table for an oral presentation at a conference, at a meeting, it'd be very difficult to explain to people. It'd be much easier to use this figure and explain things to people. Should I use tables at all? Is it okay to just write out everything in a paragraph? It would depend on the number of items you have. If you have very few variables and you could write out everything in a sentence or two and make it clear to people, then that's fine. But if you have multiple variables, then making a table is much better. So if you look at the top part of the slide, you have 3 bacteria, you have 3 numbers, and that's all that you wish to say. You could create a sentence or two and explain exactly what you wish to do or what you want people to understand. On the other hand, you have 6 bacteria, 3 different body fluids or body components or whatever you wish to call them, and you have different numbers of samples of each of these. Then you want a table for people to understand what's happening. Some common errors that people make while making tables: the titles are either too short, adrenaline and rats, or too long. Effect of adrenaline on cirrhotic and non-cirrhotic rats at 20, 40, and 60 days. So except for the actual numbers, everything else has been said within the title itself. So try and use the middle path of Buddha and use titles which are somewhere in between. Provide you enough information, but don't go to the extent of giving you all that's available within the table. So I've already mentioned an absent stub or a plural. A stub in plural is something that's often found to be an error as far as tables are concerned. Column headings could be too long. There may be no footnotes or inadequate. So you've got an asterisk, you've got a dagger, you've got a 1, 2, 3 within the table, but your footnote explains only the 1, 2, 3 and forgets to explain the asterisk and the dagger. And that becomes a problem. Sometimes the body of the table may be too much or too little. So if you have a table which has just 2 or 3 columns, ask yourself whether you need that table. I'm sure there would be place for a column or for a table with 2 columns or 3 columns, but ask yourself, can I do better than this? Or if you have a table which has 10 columns, then again ask yourself, is this too much in a table? So the New England Journal of Medicine, the Lancet, the JAMA, all these general medical journals, if you look at the tables, they often run into multiple rows and lots of columns. But generally, a good table is something that I can take in with a single swing of my head, and therefore a table with 4 to 5 columns and about 5 to 7 rows is all that you should actually have. So you have more than that, then ask yourself whether you need to split up or combine, or if you have less than that, ask yourself if it is possible to combine the tables. I'm not saying you've got to do it all the time, but ask yourself, should I do it? The International Committee of Medical Journal Editors, whom we referred to yesterday, in the recommendation suggests the table should be double spaced when they're typed out. They should be numbered consecutively using Roman numerals. They should have a brief title, a short column heading, no rules within the table itself, and the footnote should indicate any statistics and the source if you've taken the table from somewhere else. Here's an example of a table, and yeah, it's going to be difficult for someone to say, but would somebody like to take a go at it and say what's bad about this table? Or do you think this is a perfect table?
So I don't know whether these numbers depict actual numbers or percentages, or there is no labeling.
Okay. Anything else? So I don't have a table heading. I don't have a number of the table. I don't have a stub. PT is an abbreviation. WT is another abbreviation. We presume it's height and weight here, height and weight, HT and WT, but we don't know. So this is not a great table. On the other hand, once you get this, you've got a table, you've got a number, you've got a title of the table. The PT becomes an N. It tells you that's the number of patients. The WT becomes weight in kilograms. That makes a lot of sense. The HT becomes height in inches. Then you say, okay, now this makes a lot of sense. Similarly, the group 1 and group 2, the group could be moved up to the stub and you could just have 1 and 2 at the bottom. And that's a much cleaner, neater, and easily understood table. Any questions on tables? Otherwise, I'll move on to figures.
So when we are comparing two groups and say we want to mention the p-values or the odds ratio, then would you recommend just putting an asterisk and putting it in the footnotes, or make a separate column for that?
If there were two groups and I was comparing those two groups, then I would put a column at the end and explain, provide the p-values there. But if I had 4 groups and I was doing multiple comparisons, then it may become complicated. So then you've got to take a call as to whether you wish to split this table into 2, or do you want to put asterisks and daggers and put the numbers in the footnote, the actual p-values in the footnote. Now that's a call that you will have to take. For each individual table, it will be a different call. It would depend on the kind of numbers that you have, how many numbers you have, and how many of those comparisons appear. Okay.
Thank you.
Okay. Anybody else? Any other questions? All right. If there are none, I'll move on to figures. Now you heard this hundreds of times, that a single picture is equal to 1,000 words, but the picture needs to be made well and needs to be understood easily by the people who need to see this figure. So different types of figures, there are graphs, there are photographs, and there are flowcharts. As far as location in relation to the IMRAD structure is concerned, they're most often used in the results section. Sometimes they're also used in the method section to describe a technique or a study design. Figures are usually purpose specific. So different kinds of figures could be drawn based on what you wish to tell people. For example, a line drawing or a line graph could show an event in relation to time. Bars could be comparisons between groups. A pie would indicate parts of a whole. So if I wish to show a part of a whole and I draw a bar, it doesn't give me the same impression as a pie. I can draw a bar. It's not that I can't do a bar, but it doesn't give me the same sense as a pie does. Similarly, a histogram gives you frequency distributions, and a scatter plot shows you association between variables. So depending upon what you wish to use this figure for, you choose a particular kind of figure that you wish to make. You'd also have photographs. You could have pictures of something that you've done. This could be to show a technique. It could be to show steps of a procedure. It could be to compare things which are happening before and after whatever you've done. Or it could mark an event. You wanted a certain outcome, and that outcome was achieved, and therefore you want to tell people, look, this was the outcome that I was looking for, and here is a diagrammatic or pictorial representation, a photographic representation of that particular event. And only when this event occurred did I consider this to be a positive or even a negative event, whatever you wish that to be. Similarly, you could use flow charts to show processes, sequencing of the way you've done things, systems, or even develop algorithms when you come to the point of discussion. Having looked at your results, you discuss things, and then you say, based on this, we'd like to propose an algorithm for whatever, diagnosis, management, chemotherapy, palliation, whatever. Ask yourself, what do you want to say? What do you want people to understand from that particular figure that you're going to put in? Is there a better method to do that? And therefore, if there isn't, then what type of figure would be best for the data that you wish to show? Remember, less figures are better than more figures, and use figures in written text only if they are absolutely necessary. Now, figures could be line drawings, like I mentioned. They could be black and white, which in printing parlance is called half tones, or they could be in color, which is usually 4 colors, because with a mix of 4 colors, you can get all the other colors that you wish to make. So a figure has 2 axes, an x-axis and a y-axis. So provide 2 types of information. Don't get a y1 and a y2 axis. Your computers allow you to do them, but that means that there are 3 pieces of data that you're predicting on a 2-dimensional picture, and it's always difficult to understand. Therefore, it is best to provide only 2 types of information. Draw a second figure, much better. What about curves? So if you've got more than 5 curves, then it may become difficult for people to understand what's happening. If there are more than 5 curves on a figure, ask yourself, should I make 2 figures? Obviously, if you've got 7, 8, or 9, you may not. But if you've got 25, then you may want to make 2 different figures, because too many figures, too many lines on a figure is not a great idea. Make thick lines so that these can be captured well when the printer or the publisher or the editors decreases the size of the picture and prints it in the journal. Label the axes, just like your column headings need to have the n numbers, the number of patients or the number of samples studied, and also need to have the units of measure. Similarly, the x and the y axes need to have the quantity and the units. Start all axes at 0, except if you're using a log scale. Use simple symbols within your lines, simple round or simple squares. Don't use complex figures. If there are curves that are crossing each other and you feel that this may become difficult for people to understand, then you could show a break, as has been shown in the graph on the bottom right of the screen. Have a good contrast, label your figures, mention the stain used if you've got a photomicrograph. If you used a magnification, say what the magnification was, and it's useful to have a scale along with the picture of, say, a pathology specimen, for example, but it could very well be something else, not necessarily just a pathology specimen. Use color only if it's absolutely necessary, because a number of journals would charge you extra if you wanted color illustrations to be printed. Please don't put any clips or staples when you put these figures that you've got on pieces of paper, because if you were to take pictures from these pages, from these pictures that have clips or staples on them, then these would show up, and you would then need to touch them up to be able to get these clips and staple marks to disappear. What about the identity of a patient? Is masking enough? No. Today, masking alone is not enough. You need to have consent from a patient before you go ahead and publish a picture of a patient, even if it is not the full face, even if it is just the hands, even if it is just the feet, it is just one part of the body. You need to have consent, because most journals would otherwise decline to publish the picture of the patient. Every figure must have a legend. It must be brief but complete, very similar to a table heading. You need to explain any labeling that you may have within the figure. All abbreviations should have a full form written out within the legend. Most journals would want these legends to be written separately and not with the figure. However, go by whatever the instructions of the journal are. Always indicate the top of the figure, even in an electronic figure. If you send a hard copy, you always put a top mark, put an arrow also indicating the top, but do that in an electronic figure as well, because these could be very easily turned around. Place the name of the first author in the file of the figure, because if somebody were to misplace this and it goes somewhere else into some other folder or gets mixed up somewhere on the electronic software, then it can be traced easily. A brief title of the article within the file name, and a figure number, and then hopefully they'll be able to find it if they misplace it. Don't do all this within the figure, because it could compromise the quality of the figure. Here's an example of a figure which was used in the method section of a paper. Dr. Rakesh Agarwal and I were doing a workshop in Kottayam with pharmacy students many years ago. And they had this complex protocol which had been written out. We converted this into a figure. 5 groups of mice or rats or something, and spread out over a few days. And you did an interpreter inoculation of some cells, and then observe these mice over a period of time. And one figure explained all those pages and pages of methods in a very simple and easy to understand manner. Whenever you draw pie charts, it's not a great idea to do 3D pictures like this, 3D pies like this one. It's much better to use a 2D format. Same is true for bars. So Dr. Rakesh Agarwal is very fond of this. He in fact coined this term, ink to paper ratio, no wasted ink principle. So if you have 3D, you're unnecessarily wasting ink on an inkjet printer if you're using an inkjet printer or even a laser printer. Whenever you have an ascender and a descender, getting 3D could, if a person is sitting at a corner of a room and you're projecting this figure, they could make it may be difficult for them to understand whether this is actually going down or up, especially for something that is this small. That means the last one, which is group 5. So again, it's much better to do a 2D, and this cannot be misinterpreted. This is a figure which is inadequate, and I wonder if somebody would take a guess as to what it is. Anybody?
Barium studies and things.
So that's the most common answer that I get. Anybody else? No? Okay, the next most common answer is a nuclear scan, a thyroid scan. But this is what it is. It's an inferior venocavogram. It's actually submitted as a review article to us with this picture, with no labeling. And if we were to produce that picture in a journal article, nobody would be able to figure out what's happening. So much better to label your figures. Always try and get the labels off the figure on one side neatly. It's easy for people to understand what you're saying, and they can trace these things and find out what exactly is going on. That's an example of a figure with multiple lines, and I'm sure nobody can understand what's going on here. And therefore, if you have so many lines and you desperately need these lines, then it's much better to make multiple figures. However, in this particular instance, it may have been much better to put this all as data in a table. It would mean easier for people to understand what was going on. This is a neat figure, well labeled. Just an example of something good and something bad. Now, this is a neat figure, but you've got repetition of 100%. If you've got a straight line, then obviously it's 100%. You don't need to keep writing it again and again and again. So if you are not familiar with the software that's available to you, please try and get help from somebody so that you don't make these kind of figures. You could do very nice figures where you could depict changes with time. This is a figure which belongs to Dr. Rakesh Agarwal, one of his papers, which depicted changes of time in patients who were treated with, or maybe was it animals? I'm not sure. I forget. Maybe he didn't tell me when he gave me the figure. But anyway, it shows you that there is a change over time. Tells you how many patients. Yes, it was patients. How many patients received a placebo over this period of time, how many received an X amount of the drug, and how many received a Y amount of the drug. So this kind of a figure would be very useful. So whenever you make figures, use them as adjuncts, use them to convey a message. There are different types of figures, use them appropriately. If you're using a figure, ask yourself, is it needed? If you decide to make 1, 2, 3, 4 figures, make them simple, make them consistent. In one paper, try and make figures which look similar. Make them clear, make them focused on what you wish them to say, and make them visually effective. At the end, I'd say, as far as results are concerned, look at the journal instructions, read the Vancouver style or now the ICMJ recommendations, look at a recent issue of the journal. Pay attention to each component of the results section, the tables, the figures, as well as the text. Get a colleague to read what you've written and ask the person to criticize honestly. Don't get your best friend to do it. Your best friend is not going to be able to hurt you. You've got to get somebody who is able to hurt you and tell you, look, I can't understand anything that you've written, because this is a section that is likely to make or break your paper. Thank you very much.